When we buy a water filter, we want it to do three things: remove impurities that affect aesthetic properties of water, to make water taste and smell good and be colorless, to remove harmful substances, to make water safe for our health, and remove hardness to make water soft, so food and drinks cooked on this water taste better. In order to choose the right filter, let's conduct several vivid experiments. Experiment 1. Removal of colloidal iron hydroxide. An admixture that is often encountered in tap water, iron hydroxide, also known as rust, makes water look and taste bad. Although rust is comprised of undissolved particles that can be stopped by mechanical filtration, very small size of these particles makes them hard to be removed. Let's take a colloidal solution of iron hydroxide with concentration of 100 mg per liter. Such high concentration is untypical for tap water. Usually, after traveling inside steel pipes, tap water contains up to 3 mg per liter of colloidal iron. We increase the concentration in order to make our experiment more pictorial. The result is achieved due to inclusion of aqualine fiber in Aquaphor filter cartridges. When combined with fine granular adsorbents comprised of high-quality activated carbon and ion exchange resins, aqualine dramatically increases filtration performance. Experiment 2. Removal of harmful substances. Aesthetic contaminants for sure decrease water quality. However, main threat for our health comes from harmful substances dissolved in water. Active chlorine, volatile organic compounds like chloroform and benzene, pesticides, pharmaceuticals, heavy metal ions like cadmium, lead, mercury, etc. Small molecules and ions of dissolved substances cannot be removed by any mechanical filtration, but can be adsorbed by special materials, adsorbents. Most harmful substances don't affect water color when dissolved, so in order to make experiment visual, we use methylene blue, an organic dye. Intense blue coloring appears even when the concentration of the dye in the water is less than 0.1 mg per liter. The mechanism of adsorption of methylene blue is identical to that of, say, pesticides. That is why methylene blue is used as a model contaminant in various standard tests. Let's make methylene blue solution and challenge water pitchers to filter it. As we can see, all pitcher filters reduce concentration of model contaminants. However, only Aquaphor pitcher removes blue coloring completely. Experiment 3. Hardness removal. In most parts of the world, drinking water contains significant amounts of calcium and magnesium salts, also called hardness salts. Hardness negatively affects the taste of food and drinks such as coffee or tea. Moreover, when hard water is boiled, salts that form so-called carbonate hardness deposit sediment, known as limescale. To determine how well a filter reduces hardness, we use simple and vivid method designed by German standardization agency DIN. Hard water is first put through the filter and then boiled as long as it takes for scale to form insoluble deposits. This process is repeated multiple times. Then we dissolve the scale and assess its amount. The less scale we get, the more effective is the filter we used in water softening. Our experiment is qualitative, thus we will simplify it for clearer demonstration. We will simply boil water in a kettle and then examine deposits on its inner surface. As we can see, water filtered by Aquaphor water pitcher didn't form deposits during boiling, which means it does not contain much hardness salts.